Hey guys, here is the experiment interpretation video that you will run across on the ACT, or you could even use this for any other science data that you run across that presents an experiment and how to interpret this. It's not hard. Let me just run across how I do it, and perhaps it'll give you a better way to look at it. So here we go. Okay, upper left-hand corner. The first thing that we run into as we turn the page for the experiment on the exam, we see a figure in the upper left-hand corner. Now notice, it is film. And film has clamps attached to it. And the arrows are showing us force being pulled in the opposite direction. So they're stretching the film. Well, you know, this is an experiment. I want you to start getting into the mindset as if you were the scientist doing this experiment. So start to think about why you would want to pull the film. Well, if we pull the film, we might want to figure out how far it will stretch before it breaks, right? So elongating it. We also would want to know how far or how much force it would take to break it. Okay, think about film. If you've ever seen film, is it transparent or is it colorful? Does it get more transparent as we stretch it? Is it stiff? Is it easily stretched? Is it thick? If we were to lay it on over so we could look at it from its edge side, how thick would it be? Well, it's a film, and film is made up of some chemical components. So with that in mind, what chemicals within the film could be the one that's giving it its properties to permit it to stretch? And as we go through the data, what we're going to find out is the graph is going to tell us the chemical component that permits the film to stretch. In just a second. Okay, so once you've analyzed the figure real well like that, and you've thought of all the ideas that you can, then move on. Now, our upper right figure, notice there is our italicized words. And when you see italicized words, you must read the meaning of them. My question to you is, did we just predict any of the italicized words before reading them? Well, the first italicized word is tensile stress. What does it mean? The force applied per unit area of the film as the film broke. So they were testing to see how much force it took to break it. Well, we predicted that just a second ago. Percent elongation, how far the film will elongate. And they give you an equation to help you figure that out mathematically. Now, when you see an equation given, pay particular attention to it, because they're probably going to ask you to use that equation to do a very minor calculation. The last italicized word, elastic modulus, a measure of the rigidity of the film. Well, stiffness, right? Rigid. How rigid is it? If it's real rigid, the film won't stretch at all. It'll just break. Okay, now we have contemplated some ideas based on the figure. We have looked at the italicized words, and now we're going to go to the data. The graph, the bottom left, we always read for the title. There's no title, but there's a key. Make sure you understand the title or the names of both of those lines, tensile stress and percent elongation. The next thing we do is we look at the y-axis. What are we measuring? Well, on the left y-axis, we're measuring tensile stress. On the right y-axis, we're measuring percent elongation. Now notice both of their scales are the same, so that's good. Now, the x-axis tells us what we're varying in the experiment. We are varying percent glycerol. So glycerol has just been identified as the chemical component within the film that permits it to stretch, because look at the scale on the x-axis. We are increasing the amount of glycerol from 15 to 55. Now, as we increase the amount of glycerol, what happens to percent elongation? It increases. So therefore, it's telling us, or it's suggesting at this point, that glycerol is the chemical component that permits that film to stretch. Now, look at the tensile stress. As we increase glycerol from 15 to 55, the tensile stress decreases as we increase glycerol. So those two lines, if you think about their definition, does that make sense in their relationship? And yes, it does. Okay, so now the last graph, the bottom right-hand side, we are now measuring elastic modulus. Okay, well, remember, that's the rigidity of the film. We're going to look at the y-axis, look at the units it's in, from 0 to 500 to 1,000. It's increasing by 500 each time. Okay, so we're measuring the rigidity of the film based on changing the glycerol, because glycerol is on the x-axis. Glycerol is our variable. As we increase glycerol from 15 to 55, what happens to the film? What happens to its rigidity? It decreases. So it would make sense that you decrease the rigidity of the film so that it will elongate. Now, the last thing you need to do is compare the two graphs together and make sure both sets of data fits one another. And when you compare both sets of data, you see that it does, because the rigidity decreases as we increase glycerol, just like the tensile stress decreases as we increase glycerol. So the tensile stress and the rigidity are similar, they decrease. And when they decrease, it allows us to elongate when we increase the amount of glycerol in the film. Now, we didn't read anything other than the information that was given to us. Now, you should be able to go to the questions that are associated with this data and answer these questions quickly and correctly. With that in mind, I wish you all the best. And if there's anything I can do for you, please reach out to me.